Let us begin our lesson on control charts, in particular, the X-bar control chart and the R-bar control chart. The X-bar and the R charts are always used together. Control charts are used for monitoring changes in a process over time. It reveals the stability of variability in a process, and it shows if a process is in control. A control chart has an upper control limit, a lower control limit, and a center line. This is the process mean. Charts are used to monitor the variation of a process. Once the control limits have been established for the control chart, these limits may be used to monitor the variation of the process. A process is in control if there are no points outside the control limits. When a point is outside these established control limits, it indicates that the variation of the process is out of control. These are the equations used to develop an X-bar control chart. Upper control limit, or UCL, is equal to X double bar plus A sub 2 times R bar. Lower control limit, or LCL, is equal to X double bar minus A sub 2 times R bar. An X bar indicates how the average or mean changes over time. Let's say a business wants to monitor the weight of door panels they are manufacturing. The manager collects 4 door samples every day for 5 days and tabulates them. The first step would be to compute for the X bar column and range bar column. The X bar column is the mean of the samples, and then add it all up to get the summation. Then compute for the range column. It is computed by getting the difference of the largest and smallest samples, then added up to get the summation. We then compute for the R bar, or the average of the ranges. That is 2.60 in our example, divided by 5. That will give us 0.52. We then compute for X double bar, or the average of the means. That is 50.20 in our example, divided by 5. That will give us 10.04. Now we substitute these results for X double bar and R bar into the formula to find the upper control limit and lower control limit. But to find the value of A sub 2, we need a table called the factor control table. We have 4 samples. Remember, 4 samples of the weights of doors were recorded daily. So we look at the corresponding factor on A sub 2 column. This gives us 0.729. We use this factor for the formula. And so our X bar UCL is 10.40 and X bar LCL is 9.66. Now we draw a chart with the upper and lower control limits. Upper limit is 10.40 and lower limit is 9.66. Draw the center line, which is the X double bar. In this case, it is 10.04. We plot the means, or the X bar column data. Since no points are beyond the control limits, we can say the process of manufacturing door panels is in control. If a sample point goes beyond the control limit, this means the process is out of control, and what caused this variation has to be investigated. Now let us develop an R-bar control chart. The equation for the R chart, UCL, is D sub 4 times the R bar. For LCL, it is D sub 3 times the R bar. The R bar indicates how the range of the subgroups changes over time. This is utilized to monitor process variability. Compute the range column by calculating the range of the samples. Largest samples minus smallest samples. Then add all the results to get the summation. And then we compute for R bar. That is in our example 2.60 divided by 5, and that will give us 0.52. We substitute the R bar to the formula for calculating our chart upper and lower control limit. And to find D sub 4 and D sub 3, again, we have to use the factor control table. Since there are 4 samples, we look at the corresponding factors under D sub 4 and D sub 3 columns, which will give us 2.282 and 0 respectively. We substitute the values in our formula. The result is an R chart with an upper control limit of 1.19 and lower control limit of 0. Now we develop an R chart with the upper and lower control limits. Upper control limit is 1.19 and lower control limit is 0. The center line, which is the R bar, in this case is 0.52. We plot the range samples, and since no points are beyond the control limits, we can say the process of manufacturing door panels is in control. If a sample point goes beyond the control limit, this means the process is out of control and we must investigate this variation.